Exercise 3.3. In exercise set 3.3 part 1, we did question number 1 to question number 4. That was basically the finding the limits of a function that is normally in the form of indeterminate form. Now we have to solve the rest of the questions. I have already solved here. I will just explain it to you that how I did these questions. So starting from question number 5. Limit x approaches to 0 sin x over square root 1 minus cos x. Before putting the limits, we will simplify this function and then we will use the limits in this function, and if it becomes in the indeterminate form, then we will use the L'Hopital rule. So first we have to simplify this function. This x can be written as 2 into x over 2. So write in place of x 2 into x over 2 so that we can get a form of sine 2 theta. Sine 2 theta is an identity that is equals to 2 sine of theta cos of theta. So I replace sine 2 into x by 2 as 2 sine x by 2 and cos x by 2. Now come towards the denominator. Same thing you have to do with the denominator x here. Write 2 into x by 2 and then we can use the identity cos 2 theta equals cos square theta minus sine square theta. So write in place of cos 2x by 2 as cos square x by 2 minus sine square x by 2. Write the brackets as we have minus sign here and that can change the inner signs. So write the bracket. Now open the brackets, numerator remained as it is, then 1 minus cos square x by 2 minus minus will become plus sine square x by 2. Now we know very well that sine square theta plus cos square theta equals to 1. Here we have 1 minus cos square. So that can be equals to sine square theta. In place of theta, we have x over 2. So in place of 1 minus cos square x by 2, we will write sine square x by 2. And this sine square x by 2 came as it is. Now in the denominator, sine square x by 2 plus sine square x by 2 will become 2 sine square x by 2. Remove the square root. The square root will separately be written on 2 and separately on sine square x by 2. Square root of 2 is written as it is and square root of sine square x by 2. This square will be cancelled with this square root. We will get sine x by 2. Now we can cancel this sine x by 2 with this one, and we know very well this 2 divided by square of 2 can be simplified further. 2 divided by square root of 2. We know very well simple 2 can be written as square root 2 into square root 2. We can cancel this and we will get square root of 2. So here we got square root of 2 cos x by 2. Now use the limits x approaches to 0 into this function. We will get limit x approaches to 0 square root 2 cos x by 2. Use the limit x approaches to 0. 0 in place of x we got cos 0 by 2. So square root 2 cos of 0. Cos of 0 is always equals to 1. So I have written 1 here, and then 1 multiplied by any number will always give you that number. So this is the solution of question number 5. Move on to question number 6. Limit x approaches to 0, tangent x minus sine x over x squared tangent x. See, in the previous question, we don't find the need of using L'Hopital rule because we haven't got the indeterminate form. So sometimes when we simplify the function, we avoid the L'Hopital rule as well. So question number 5 was simply solved by simplifying the function. Now same will happen in question number 6. Tangent x. This tangent x can be written as sin x over cos x. minus sine x is written as it is. Then x square tangent x. Again tangent x can be written as sine x over cos x. Just simplify this numerator by taking the LCM. We got sin x minus sin x cos x divided by cos x. We got one fraction in the numerator. Denominator remained as it is. Now we know very well this is the denominator of upper numerator. It will go down, and this cos of x can be cancelled with this cos of x. So we got only sin of x minus sin x cos x. We got this term and this one. X square sin of x. Take sin of x common as in the numerator. We got 1 minus cos of x divided by x square sin of x. This sin of x can be cancelled with this sin of x. And we will left with this sin of x cancelled with this sin of x. We got 1 minus cos of x over x square. If we put limit in this, we will get 1 minus cos of 0 over 0 square. That is equals to 1 minus 1 over 0. That is 0 by 0 form. Now we can use the L'Hopital rule because we cannot further simplify this function. So use the L'Hopital rule, and you know very well that what is L'Hopital rule? You have to differentiate the numerator separately and you have to differentiate the denominator separately. Differentiation of 1 will give us 0. Minus cos x when differentiated will give minus sin x. X square, differentiation of x square will give us 2x. Minus minus plus sin x over 2x. Now 1 over 2 can be separated. This is a constant. There will be no change when we will use the limit on this constant. What we will left behind? Limit x approaches to 0, sin x over cos of x. Sin of x over x. We know very well this is an identity and this is directly equals to 1. So 1 by 2 when multiply with 1 will give us 1 by 2. Now come on to question number 7. Limit x approaches to 1, n x raised to power n plus 1 minus n plus 1 x raised to power n plus 1 divided by x minus 1 whole square. When we directly put x approaches to 1 in place of x here, we will get 0 by 0 form. And we know very well this is an indeterminate form. So we will use the L'Hopital rule. In using the L'Hopital rule, we have to differentiate the numerator and then we have to differentiate the denominator. This n is written as it is. The differentiation of x raised to power n plus 1 is power down, that is n plus 1, then x raised to power n plus 1 minus 1. Then move on. N plus 1 is a constant. It will be written as it is. Then differentiation of x raised to power n is n x raised to power n minus 1. Differentiation of 1 is 0. Now come to the denominator. Differentiation. Before going to differentiate this x, we have to deal this power. So power down, power minus 1. And then the differentiation of inner function without power will give us 1 minus 0, that is 1. Now, simply in the last step, x raised to power n plus 1 minus 1, this 1 will be cancelled. We will get x raised to power n. So here we got n into n plus 1, x raised to power n, and the last function in the denominator as it is. Now we see that n into n plus 1 is here and also with this function, so we can take it common. So n into n plus 1 is taken common and we are left behind x raised to power n minus x raised to power n minus 1, and the denominator will come as it is. This is the constant term. This is also a constant term. We can separate it. And we will left behind x raised to power n minus x raised to power n minus 1. We can again take something common from here. How we can take it common? We will simply make x raised to power n as n minus 1. We know very well n can be written as n minus 1 plus 1. So I wrote it here like plus 1 minus 1, added and subtracted 1. Then I separated using the exponent laws. with the same base. I separated n minus 1, x raised to power n minus 1 into x raised to power 1. If we multiply it, we will get back this function. And this is written as it is and denominator as it is. Now I can take common x raised to power n minus 1 and I will be left behind x raised to power 1, that is x, and here we will be left behind minus 1. We can cancel this x minus 1 with this denominator x minus 1. And then when we will put the limit in this, in place of x as 1, we know very well 1 raised to power any number can be 1. So when 1 will be multiplied with this function, we will get n into n plus 1 divided by 2. Question number 8. Limit x approaches to 0, e raised to power x minus 2 cos of x plus e raised to power minus x divided by x sine of x. If we put limit x approaches to 0 in this function, put 0 in place of x here, we will get 0 by 0 form. So we have to use the L'Hopital rule here to simplify it. Take the derivative of the numerator, that is, we know the derivative of exponential function is exponential function as it is, and the derivative of power. And the derivative of power will give us 1 here. Then minus 2 as it is. Derivative of cos x is minus sin x. Plus e raised to power minus x is derivative will remain e raised to power minus x. And the derivative of power that is minus x will be minus 1. When we will take the derivative of denominator, we know that this is in the product form. So use the product rule. Derivative of x will be 1, sin x will remain as it is, plus. Now x will remain as it is and take the derivative of sin x, that is cos of x. Now rearrange it. E raised to power x as it is, minus plus 2 sin x, minus e raised to power minus x, and the denominator as it is. Again, if we put 0 in place of x here, we will get an indeterminate form. So again use the L'Hopital rule. Differentiate the numerator. E raised to power x will remain as it is. As we know, the derivative of exponential function is the same exponential function and then the derivative of its power. 2 sin x will be 2 cos x minus e raised to power minus x, and again the power of the derivative of this power will be minus 1. Derivative of sin x will be cos x. Now here we have to use the product rule, that is take the derivative of x and take cos x as it is. So 1 into cos x plus x as it is and take the derivative of cos x, that is minus sin of x. Now simplify this fraction. This minus will become the plus and this minus plus will become minus. Then simply cos x plus cos x will become 2 cos x. Now put the value 0 here. We know e raised to power minus x is 1 over e raised to power x. Now put 0 in place of x everywhere in this fraction, and then we get e raised to power 0 is 1. Anything having power 0 is always 1. Cos of 0 will give us 1. E raised to power 0 will also give us 1. Cos of 0 is 1 and 0 sin of 0 will give us 0. So just simplify it. 1 plus 2 plus 1, because 1 over 1 will give us 1 divided by 2. So we got 4 divided by 2, that is equals to 2. 2 1s are 2 2s are 4. Move on to question number 9. In question number 9, limit x approaches to 0, ln 1 minus x square over ln cos x. Put 0 in place of x, we will get ln 1 minus 0 divided by ln cos of 0. That will be ln 1 over ln 1. And we know ln 1 is 0, ln 1 0. So we got 0 by 0 form. Use the L'Hopital rule. Take the derivative of numerator and take the derivative of denominator. The derivative of ln function is always, for example, if we take the derivative of d by dx of ln x, it will always be 1 over x, and then the d by dx of this inner value x. Now ln 1 minus x square, derivative will be 1 over 1 minus x square, and then take the derivative of this inner function, that is 0 minus 2x. Same thing will happen with this denominator. Ln cos x will be 1 over cos x, and then take the derivative of cos x, that is minus sine of x. Rearrange it. Okay, we have two fractions that are dividing with each other. So for simplicity, if you got confused in solving these two fractions that is already in a fraction form, then use this method. Write this numerator as it is. Use this line, this division line, as a division sign, and then the denominator. Change this division sign into multiplication, and then just invert this fraction. The denominator will become the numerator, and the numerator will become the denominator, like this. Now multiply numerator with numerator and denominator with denominator. We will get this. Again, if we put 0 in place of x, we will get 0 by 0 form. So again, using the L'Hopital rule, limit x approaches to 0. This is a product form. So I am treating this as one function and this is another function. So first take the derivative of this. This will be 2. Cos x will remain as it is, plus. Now take 2x as it is and take the derivative of cos x, that is minus sine of x. Now again we have two functions in the product form. First take the derivative of sine x and keep this second function as it is, plus keep this first function as it is and take the derivative of 1 minus x square. Simplify the terms and then put the limit x approaches to 0 into this. We will get simply 2 minus 0, 1 minus 0, that is equals to 2. I hope you understand till this question number 9. For the rest of the questions, you have to just remain updated regarding the coming videos. Thank you so much.